So this is the main page for VexID. It's a very simple web page, and basically I tried to keep it as simple as possible because I want it to be really accessible for all kids in all classrooms, no matter what kind of literacy or technology skills they have. So it's very simple. There's an identify and a read button, and it's in 3 different languages. Right now, you just put this part in front of your camera. In a real deployed setting, I would have some kind of setup so that the camera is always in a similar place. But here, you just set it down, hit identify.
3x5 right angle beam.
It'll identify it, tell you what it is, and then you can test it with like different parts.
4x4 offset right angle beam.
And it can figure all of that out, and then if you hit read.
This beam can be used for big parts in the base of a robot that need different directions. It can be used as a large claw, and for parts of your robot that need to be far away.
Yeah, so it'll give a very brief description about what this kind of piece could be used for, to hopefully get these kids thinking about what they might want to actually do with this part, and to help them get a better understanding and grounding of where they are within the space of Vex. So, I mean, and it works with all sorts of different orientations because it was trained in 3D. If we wanted to switch back. Let's try something tricky.
3x5 right angle beam.
Yeah, so it's still able to get it. So this is the code that I used to run my image generator, and it's able to generate over 30,000 images of training data. It uses domain randomization, which is something that was introduced in this paper, and it works really simply. It's pulling these parts directly from the CAD files, and then it will generate a folder based on those CAD files. So you can see the images coming out as they're being generated. They look like this. And everything, like with domain randomization, everything is randomized, so the background is randomized, the lighting is randomized, and pretty much everything like that. The other thing that I also wanted to show is the shield. First, it will generate a depth map. The depth map will look something like this. So it shows an AI estimation of what the depth is at every point. And then this depth map is encoded back into the original image. So in this case, it's the depth map becomes the blue channel of this image. And this is something that hopefully the image classifier model will be able to use and should make the process a little bit easier for this. And this is something that I'm still developing. This has been an overview of all of the different aspects of the VexID pipeline. Has a very simple end result, but a very complex back end. But I think that it'll be very helpful to help teach these kids all of these different parts and hopefully lead them to learn a little bit more.